Welcome back to another exciting pre-class video. This time we'll be looking at modeling using exponential functions. Remember that an exponential function is in the form a times b to the x, where a is the initial value and b is the growth factor that we're multiplying by for each time step. So in order to create an exponential function, we just need to find the value of a and b that fits our data. In order to do this, we're going to introduce another variable r called a growth rate, describing how much the function is growing, not as a percentage, but as a decimal. And this will help us because we can define b to be 1 plus r. And this will work whether our growth rate is positive or negative, as we'll see. So let's create an exponential function to model the situation where we start with 65 wolves being released into Yellowstone National Park, and then they thrive in the park and grow by a rate of 3.5% each year. We know that our function f of x is going to look like a times b to the x, where a is our initial value, and b equals 1 plus r is our growth factor. In this case, our initial value is a equals 65, and our growth rate, r, 3.5% is 0.035 as a decimal. b equals 1 plus r, that's 1 plus 0.035, meaning that our final equation, f of x, is a, our initial value 65, times b, 1 plus 0.035 to the x. And if we want, we could write this as 1.035. Let's do one more example. This time we have a car that was purchased for $24,000, and now it's depreciating by 7% each year. Once again, our cost function will look like a times b to the x, where a is our initial value, b is 1 plus r, our growth factor, and this time our growth rate, since it's depreciating or decreasing by 7%, we can say r is negative 0.07. This time, when we write b equals 1 plus r, we'll actually be writing 1 plus a negative number. Putting this all together, we have our cost function c of x is our initial value, 24,000, times 1 plus negative 0.07 to the x, or equivalently, 24,000 times 0.93 to the x. Since our growth factor now is less than 1, this shows that this is decreasing exponentially.